What's going on, everybody? It's me, Side Project Dev. If this is your first time on the channel, what I do here is I take stupid side projects I always wanted to work on and build them, typically in Typescript for the web. Today we're going to rebuild the wireworld computer. Wireworld is a cellular automaton with only 4 types of states: empty, head, tail, and conductor. The rules are as follows: head turns into tail turns into conductor, and conductor turns into head if it has exactly 1 or 2 neighbors. Using these rules, you can build logic gates, which of course means you can build a computer, which is exactly what some guy did. Now, I'm not going to rebuild this computer, I don't know how to, but what I am going to do is steal the source for it and build an engine to run it using Typescript and Canvas. First things first, I'm going to set up and define my splits. This includes setting up GitHub, setting up Vite, getting drawing working, and a few optimization iterations. My goal is to get this done in under an hour. First, I'm going to head to GitHub and create my repo. I wasted about 2 minutes trying to find the button, which I'm honestly not sure why I couldn't find it. I'll add a simple license and start a WebStorm Vite project. I really like WebStorm over VS Code, and hopefully in time you'll see why. VS Code is great, but it's a wet blanket compared to WebStorm, so long as you have big boy RAM. The next thing I do is delete the React stuff after deciding I just want to go straight DOM since it's easier with Canvas-based stuff. Finally, we can start working on our project about 5 minutes and 34 seconds in. So I probably want to have some class to manage state, have some thing to manage. You can see I'm using GitHub Copilot. Manage drawing. Now that we're done thinking, let's start writing some code. I start with creating a main function because I wrote C# for 10 years and I'm a sucker for nostalgia. Then I create my canvas and attach it to the root node. I then set the fill style to black. I then start defining some rough constants for board width and height. Set that to my canvas width and height, and fill my first rectangle. I start playing with the constants, knowing eventually my computer will be tall and thin. Now that I have my drawing done, I can finally split at 8 minutes and 11 seconds and can start working on my actual logic. I'm going to create a class for my wireworld logic because that's what makes the most sense to me, and then start plumbing the logics. I decide to create a 2D array class so I don't have to do the math lookup from 2D to 1D every time, and simplify my wireworld class logic. I let Copilot do most of the heavy lifting here because I can't be bothered to write the getter and setter myself. I then initialize my grid with some arbitrary values, add more getters and setters, making the array class irrelevant, and double down on over-engineering by making it generic. Finally, I start defining my wireworld states. I leave some comments so Copilot will play nice later, and start working on my draw function. I fumble over some WebStorm shortcuts, but finally land on a simple XY loop where I switch on every state, set the fill style, and then fill rect thanks to Copilot. I'm going to start plumbing a draw scaling variable because I know this will get pretty big later. Now I'm going to finally initialize my class in the main function, set some cell, and draw for the first time. The fact that it doesn't show up is quite concerning to me, but I push forward. Okay, we don't have anything yet, when we really should. Time to fire up my trusty Chrome debugger and see what's happening. I'm stepping through each line of the executed code. I realize here that I was setting a value out of bounds and the JavaScript overlords never let me know. After fixing this, we have our first pixel. My drawing is very janky because I was not initializing my board with zeros, so the draw code was not working correctly. So I'm going to fill it with zeros to start off, and now the blacks are drawing correctly. To test this out, I'm going to draw a line of them just to make sure my draw code is working. And now we can finally start working on our tick. This is the method that will be called for every iteration in our automaton. The logic here is pretty simple, so I'm going to disable GitHub Copilot so as not to steal the fun from me. I'm going to start by stealing the double loop from above and start my logic switch case. I realize that since I will be modifying the grid for each element, I will need to first clone the grid so I can manipulate it without affecting the run. Now I can start writing actual business logic, setting 0 to 0, 1 to 2, 2 to 3, and 3 to 1 if there are 1 or 2 neighbors. To facilitate this, I'm going to start writing my neighbor count code. Spoiler alert, this one function is going to prove to be the cause of a number of bugs, mostly due to silliness around incorrect usage of min-max. I'm not sure why exactly, but I always mentally struggle with min-max, using the wrong one at the wrong time. This actually would have been a great use of Copilot for the record. I'm going to skip over the center cell, create a count variable, and increase it every time the grid XY is equal to 1. Now for our logic, if the neighbor is 1 or 2, then set the copper to head, otherwise set it to copper. I'm burying the lead a little here because I am unnecessarily setting the values that don't change, which will be an easy win later when we optimize. Finally, I set the grid to next grid, and start drawing a copper horizontal line, with a head at the beginning to test my logic. While my drawing is working, I update the colors to make them a little brighter, and start the general game loop with a set timeout. It's at this time I realize that my count neighbors is wrong and start debugging the best I can, trying different values to see how it affects things, when I suddenly realize the reason my game isn't moving is because I use set timeout instead of set interval. Oh my god, I'm doing set timeout instead of set interval. Set interval, sorry guys. I initially get excited thinking my logic is done, until it still doesn't work, and I increase my bug counter to 2. After some more debugging and conditional breakpoints, I track things down to my count neighbors function for the first time. It's not returning correctly because of my min-max code. As I begin to run the calculus in my head unsuccessfully, and question my abilities as a senior architect 4 or 5 times, I finally get it working at 29 minutes and 31 seconds. Although this would be short-lived, as I realize I'm still slightly off. For now, it will be off to importing the giant computer file. I'm going to use vite import raw to read the full text contents and then start splitting up the file to add it to my game board. But not before realizing that my neighbor code is still busted. Okay, it's gonna go... It should be going the other way too, actually. It's only flowing in one direction. This bug was due to my loop missing the equal sign, so I was not checking all possible neighbors correctly. A bug that I had since I first wrote the function, which brings our bug count to 6. With that out of the way, I can start chopping up my string. I'm going to split on new line and then split on empty string, which will give me each individual character in the file that I can set into my class. First, I do a little refactor to expose the width and the height of the board. Then I build the switch case for each character which in this case is a tilde, an @ symbol, a space, and a pound. Yes, I call it pound because I'm 36. I end up running into my first bug here because I'm including /r's. Since I'm on Windows, my files save with not just /n's but /r's. This is a common occurrence for Windows developers, so I quickly resolve it. The next issue is for some reason the first few lines of the file are blank, which is throwing off my lazy zero.length, so I have to use math.max to spread in the length of every line, so that I can use the longest line's length as the width. With that out of the way, I finally get my computer drawing, and with that I can split. Oh, there it is! Okay. I'm going to do some minor refactoring here to adjust the canvas size to reflect the board so that it will scale properly. With the computer imported, you can see the different parts of it running. It's at this point that I realized that things are running incredibly slow, so I started my optimization split. I timeboxed myself to just 10 minutes to make it run as fast as I can with the current implementation. The first thing I do is check the profiler and see why things are moving so slow. Remember, you never want to optimize without measuring first. I start running the Chrome Performance Profiler. This is a really powerful tool that gives us fine-grained insight into what our application is doing. What I realize is the draw code is currently the slowest part of the application, so the first stop is making draw faster. We're going to get rid of the case 0, which is painting unnecessary black squares every time, and simply fill rect the board before each tick. I run into a bug because I'm not clearing the fill style, so it's just painting whatever the last set color was over everything, which is making the game look insane. Finally, I realize I'm just calling fill rect no matter what, which is a bug. After cleaning this bottleneck, the game runs way faster. Way faster. To push things to the limit, I increase the number of times I tick to 100 per draw, to bubble up any more performance issues in the code. We see that our draw function is much faster, but our tick is still taking a considerable amount of time. We're going to click into the tick function and see if the profiler will give us any more insight on where it's spending its time. We'll step into the code for the tick and see where Chrome is spending the time in the function. I notice that I'm reading the grid height variable for every iteration, which is pretty wasteful, but most importantly, the neighbors call is very slow. Since we're doing the max and min calls so often, and since I know this file doesn't actually have any cells near the edge, we will opt to just remove them. The other issue is the turn area at the bottom, which is very slow since it has to run a conditional check. I make a list of things to fix this iteration and get on my way. I remove setting the copper back as it's unnecessary, and then I add a flag to the wireworld class for skipping bounds checking and clean up the code. I then opt to use an array lookup versus a conditional lookup, since this should be considerably faster in JavaScript. I then break early if there are exactly 2 counts. This actually ended up being a bug that I fixed later. I run the profiler again to see the ticks running way faster. Much more garbage collection than before, but I think that's just a result of my code running more. I consider removing this conditional check, but after doing the math, it seems like it would be faster to actually leave it in. I add a console.time before and after my tick calls, which is something I should have done much earlier, so I can easily profile and see what's going on. It takes about 400 milliseconds per tick, so long as there is no garbage collection. This feels fast enough, but I have one more trick up my sleeve, which is to use a uint8 array instead of my number array, which brings it down to about 240 milliseconds per 100 ticks, which is about 40% faster for free. And that's that! We've built and optimized the wireworld computer down to 2.4 milliseconds per iteration in about 55 minutes. In the next part of the series, we will use other silly techniques like WebAssembly and WebGPU to further bring these numbers down. If you want to see me struggle through that, hit that like and subscribe, and I'll see you in the next one.